Hey everyone, welcome back to my number sense series. In this video, we're going to be doing arithmetic sequences part 1. So, with arithmetic sequences, we're going to be learning two things. The first thing is how to determine the terms of the sequence, and the second thing is how to determine the sum of the sequence. So, in this video, we're going to be doing the terms, and the next video, we're going to do the sums, just so you know what's going to happen here. So, first of all, what is an arithmetic sequence? Well, an arithmetic sequence is defined as a sequence of numbers in which the next number is greater than the previous, or simply has a common difference added to it from the previous. So you have a plus d, so where d is the common difference, that number that you add at each step. And then you have a plus 2d, so you can see at the third step we're adding another d, and each term after that we get one more d. For example, an arithmetic sequence could look like 1, 4, 7, 10. Here the common difference would be 3 because at each step we are adding 3, and a would be 1. A is the starting number. Now, if you remember the video counting numbers, you might recall that the sequences I showed you in that video were essentially arithmetic sequences. 1, 4, 7, 10, blah, blah, blah. I just didn't call it an arithmetic sequence at that point necessarily, so it wouldn't be overly complicated. But now that you know how to do that, we can use that knowledge to help us here, or in the next video as well. So the first thing that we have to do, and the most important thing that we do in this video, is figure out how to determine the terms of an arithmetic sequence without actually adding all of them. So for example, if I wanted to define the 1000th term of this sequence, I guess you could add 3 a bunch of times until you got the answer, but that would take a lot of paper and a lot of brain power and it would be a waste. So we want to figure out a better way to do that. So to do that, we first have to find a pattern, and then we're going to see if that pattern leads us to a formula, and then we're going to see if that formula holds. So I have here the first 4 terms of this sequence, which we will often denote in a sequence as a sub 1, a sub 2, a sub 3, and a sub 4. So they are 1, 4, 7, and 10 respectively. So we see that each step we add 3. So you might think that it looks kind of linear, like a line, right? So you might notice that this is 1 plus 0 times 3. This is 1 plus 1 times 3. Well, this is 1 plus 2 times 3, and this is 1 plus 3 times 3. This looks pretty familiar, right? 1 plus, so we have 1 plus in everything, and then we have something times 3, and the only thing that changes between these terms is that something that is being multiplied by 3. For example, it goes from 0 to 1 to 2 to 3. And notice that the number that you multiply by 3 is always 1 less than this number, which we call the index. This is the one that determines which term of the sequence we're on. For example, the 4th term has index 4, and so we're multiplying by 3 over here. Whereas the 3rd term has index 3, and we're multiplying by 2 over here. So you might conjecture that a formula for this arithmetic sequence would look something like this. A sub n, so the nth term of the sequence, is equal to 1 plus n minus 1 times 3. And you can absolutely confirm this by just doing a bunch of examples until you have convinced yourself. We can also prove this more mathematically, but hopefully this will be enough for you to convince yourself that this is the correct formula. And so now we start to think, how can we generalize this formula, right? Well, hopefully you can see where the parts of the formula kind of come from. This 3 is d, the common difference, and this 1 is a, the number that we start with. And n minus 1 is our variable in this case. So we might say that this is the formula for the nth term of an arithmetic sequence, and it is. So pay close attention. This is kind of what we think of as the basic formula for an arithmetic sequence. If I were to give you, the first term and the common difference, you could calculate any term you wanted using this formula. And it's not a super complicated formula at all. But in case any of you are still confused, allow me to give you a visual explanation. So, once again, we're going to use this fence post analogy that we use in counting numbers. So we'll think of this as the first term of the sequence, the 2nd, 3rd, 4th, 5th, 6th, 7th. So let's think about it. This first one is A, and in between each of the fence posts is like a distance D, right? So like this is distance d, this is distance d, 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 d. So we can see that when we go from fence post 1 to 2, we're adding 1d. So this is going to be a plus d. And when we go from fence post 1 to 3, we're adding like 2d's. And so on and so forth. So we might think, how do we calculate the distance between fence posts? Well, we can see that if we wanted to calculate the distance between, for example, fence post 1 and fence post 3, the answer is 2d. And the answer is 2d because 3 minus 1 equals 2, and 2 times d equals 2d, which is the distance. So the distance between post A and post B is b minus a times d. Basically, you subtract and you multiply by d, the distance. And so then you might start thinking about, okay, what's the distance between post 1 to post n? And of course, n here is just, a index that we're trying to find, like the nth term of the sequence. Could be 10, could be 100, could be 9 billion. Post 1 to post n, well, the distance is going to be n minus 1 times d. Just like how for post 1 to post 3, it was 3 minus 1 times d. For post 1 to post 4, it will be 4 minus 1 times d. So from post 1 to post n, it's going to be n minus 1 times d. Then we can't forget to add the a. And so we arrive at the same formula, a plus n minus 1 times d. So hopefully this is enough to convince you and inform you on how and why this is the formula for the nth term of an arithmetic sequence. So now let's get to applying it. Well, we don't exactly apply it in the first question, but this is more of a test to make sure that you really understand what an arithmetic sequence is. So hopefully you do. In an arithmetic sequence, it's just where this term and this term, this term and this term, each term differs from the previous one by some number that remains constant. Of course, it's pretty easy to determine the number. We just have to subtract one term from the other. So for example, here, d, which we call the common difference, so d equals, for example, 10 minus 4 equals 6. We also could have done 16 minus 10 equals 6. And of course, either of these are valid because d is constant. So d equals 6. So we know the next term is also going to be increasing by 6. So the next term is going to be 16 plus 6 equals 22. Now, here's a slightly harder problem. What is the 10th term in the arithmetic sequence 3, 7, 11, 15? Now here, the numbers aren't so big that you can't just list it out in your head and get the correct answer. But remember, this is number sense, so we are concerned with doing everything as efficiently as possible. So we can apply a formula. A sub n equals a times a plus n plus 1 times d. So what's a? Well, a is just the first term in the sequence, so it's 3. What's n? N is the nth term, so it's 10. 10 minus 1 times, what's d? Well, d is 7 minus 3, or 11 minus 7, or 15 minus 11. It doesn't really matter, because d is, again, constant, which defines an arithmetic sequence. So d is 4. So we know that the answer, after we evaluate this, is going to be 39. Now, another thing I should mention is that it's actually not strictly necessary to use this formula exactly. Because if we go back to this fence post analogy, we understand that in order to calculate what the value of, for example, fence post 5 is, I can go from fence post 1 to fence post 5, but I could also just go from fence post 4 to fence post 5. So here, we could have gone, instead of term 1 to term 10, we could have gone from term 4 to term 10. And what that would have looked like is 15 plus 10 minus 4. So 10 minus 4 is like the number of gaps there are between post 4 and post 10, and then 4 is the distance of each gap. And so this would have also given us 39. However, when possible, I do just like to use this because it's more, constant. It's just like, if you know how to do this, you know how to do the problem. But of course, if this happens to simplify your calculations, by all means, feel free to use it. So, the 6th term in the arithmetic sequence 89, 75, 61, is So this is a bit of a different question. First of all, notice that the numbers are bigger than we have over here. And also, here the arithmetic sequence is decreasing, which is totally valid for an arithmetic sequence to do, because all that means is that d, the common difference, is negative. So we can still find d. D would be just the second term minus the first term, which is 75 minus 89 equals negative 14. And now, in order to find the sixth term, we can, do either of the things that we've done here. If you would like to start from term 1 and go to term 6, you can do that. Or if you'd like to start from term 3 and go to term 6, you can do that also. I'll do both just to show you what it looks like. So term 1 to term 6, that would look like 89 plus 6 minus 1 times negative 14. And this would be 89 minus 70, which is 19. If we were to go from post 3 to post 6, it would look like 61 plus 6 minus 3 times negative 14 equals 61 minus 42 equals 19. So you can see either way we get the same answer. It just depends on which calculation you want to do. But honestly, in the heat of the moment, you might as well just pick one and go with it. Last question, it's not going to be much harder than the rest. The 15th term in the arithmetic sequence 28, 25, 22, is, so this is another decreasing arithmetic sequence, so all that means is simply that the common difference, d, is negative. So first of all, what is d? Well, d is 25 minus 28, or 22 minus 25, whatever you want, but it equals negative 3. And the 15th term, well, to do that, we have to know one of the other terms. We're going to use one of those other terms as like an anchor point. I'll just pick the first term. We have a equals 28. So a sub 15 is going to be, once again, if we use our formula, this, we're going to get 28 plus 15 minus 1 times negative 3 equals our answer of negative 14. And you can also confirm this by starting from number 3 or number 2 if you wish. So that is how to determine any term in an arithmetic sequence. This, along with summing, is going to be pretty much everything that number sense is ever going to ask you about an arithmetic sequence. And you can see, despite the notation maybe looking scary, the idea is very simple. It's just really this fence post thing, just adding d's all the time. So if you understand where this formula comes from, I would say you are absolutely set for this part of arithmetic sequences, and the next part won't be too much harder as well. Thank you guys for watching, and I'll see you next time.